All right, so picking up on our 3A.5, part two, we have here a mass on a spring oscillates back and forth and completes one cycle in 25 seconds. Its maximum displacement is 6 centimeters. Write an equation that models the motion of the spring as released from a maximum height. Find the frequency of the behavior. Okay, so we're trying to identify what is happening here. So the spring is released from a maximum height, and it's going to do what? It decreases. So it's going to go, I'm up here, right? It's going to decrease, and then it's going to bounce back up, right? So if you're thinking about in terms of one of our trig functions, I'm up high, I go down, I come back up. Which trig function am I modeling here? Cosine, so that it's not at the origin. Exactly. Yes. You're so smart. Yes. Okay. All right. So we understand kind of like our goal here is cosine, right? Now, for cosine, we need to figure out what's our A and what's our B. Okay. So our A is our amplitude. So in the case of this problem, out of the values that's given to us are 25 seconds and our 6 centimeters. Which one would be our amplitude? The 6 centimeters. So we know that our amplitude equals 6 centimeters. So therefore, our A value is 6. Yes? Okay, so we know our function, we know our A, now we need to find our B. Okay, in order to find our B, we're going to take into fact of our time over cycle. So this is our time over our cycle is 0.25 seconds. So that's how long it takes us, right? So when we talked about, can I go back a slide real quick? That's our period. So anytime it's the time over the cycle, that is our period. And we know that period equals 2 pi over B. Huh? Yes, we are. Okay, so our period is the time over the cycle. And our period equals 2 pi over B. So it tells us here how long it takes us to complete one cycle. So to complete one cycle, did I write circle? I think I don't know what I wrote right there. I was like, who wrote that? It was me. We don't need the question anymore. So our time is 0.25. And how many cycles is that in 0.25 seconds? 1. That's why that's our period. Okay. So period equals 1/4, which equals 2 pi over B. So what does my B equal? 8 pi. I would just cross multiply, right? So we get B equals 8 pi. Now I have my period. I now have my A. Can I write my equation? Yes, I can. So we're in terms of distance. So D, our output, and in terms of time. So we know that our A is 6 cosine. And what's our B value? 8 pi. And it's in terms of time. So that is our equation. Okay. Now it says find the frequency of the behavior. Your frequency, it's the reciprocal of your period. Do y'all remember that? Let me go back real quick. Your frequency is the reciprocal of your period. Make sense? Okay. So we know that our period was equal to 1/4. So therefore our frequency equals what? 4. And that means that it's 4 cycles per second would be completed. And we can double check that to make sure. Well, 4 cycles means I've gone a whole second. That makes sense. We did it. So we found the equation. We found our frequency. How do we feel? Good. Okay. Do we understand why it was cosine? Yeah. Why we were cosine? So we had at the initial, we did not start at the origin. We started at our highest value. So when I pull that, that frequency, that spring is already pulled down, right? So it's already stretched out at its highest situation, right? And so this is where I'm at 0. As time goes on, what happens to that spring is going to do what? It shrinks. So there's a decline in my distance. And then what happens with springs? They do what? They bounce back up. So it's going to go up, then it's going to go down. It's going to go up and it's going to go down, which is why it's a cosine situation. Yes. Cool. Sine goes, well, cosine went down. This situation, we went down, then we went up, right? So cosine is more of where you're going to have a maximum and a minimum situation. So that is going to reach a max, come back down to a low, and then level out. Okay, because you have to get back to the x-intercept, right? So it's going to have to level out at some point in terms of the situation. All right. So concavity. We've discussed concavity as a non-trig function, right? With our polynomials and our quadratics. Well, quadratic is under polynomial, but logs, exponentials. We've been doing concavity all year long, right? So we know that a point of inflection occurs where a graph changes concavity. So the 5 key points of a sinusoidal graph can be named as intercepts, max, and minimum values. You can also name the critical points as upper bounds, lower bounds, and equilibriums. So like where it's leveling out at. Let's look at a practical application and consider. So first up, it says, consider the graph below. Find the 5 key points of one period. So we're trying to make one period here. So we're going to identify our 5 key points. So our 5 key points are going to take place of one period. And what kind of graph is this, by the way? Good job. So for the first phase, these are my 5 key points. Do we agree? Okay, so we're at 0, 0. We're at pi over 6, 3. We're at pi over 3, 0. We're at pi over 2, negative 3. And we're at 2 pi over 3, comma 0. Now we're going to identify where the function is concaved up and concaved down. Okay, so when I'm looking for concavity, I'm looking for what? Do y'all remember? Where does it start and where does it end, right? So where does my, let's do concave up. If I'm looking for, good job. We're concaved up, going to always be parentheses, pi over 3 to 2 pi over 3. Are you okay if I did C up? We got that. Okay, cool. And then if I'm going to be concave down, there we go. Exactly. So I can continue, but because I'm only using the 5 critical points. So based on our 5 critical points, these are my 2 intervals of concavity, right? Because after that, it goes here, 2 pi over 3 to pi, right? So I'm only going to look there. Bless you. Yeah. You're going to use brackets when you're describing intervals of increase and decrease, and if it's equivalent at the domain or range. No, not with concavity. Concavity is just parentheses. Oh, yes, I repeated myself. Thank you. You don't see that too. We don't put the other part of. No, only where your phase was taking place, because it says analyze a phase. All right, so now we're going to look at our intervals of increase. And like we said, in decrease, when we're describing the intervals of increase and decrease, we're going to be using brackets. Okay, so where is my first interval of increase? 0 to pi over 6. Remember, it's always defined by your x. Okay, where do I have another interval of increase? No, I'm gonna say that you would only use where you define your phase to be. That's where our complete phase is, right? Okay, then our interval of decrease. You only have one, right? Is this something we feel confident and comfortable doing? Key points, concavity, increasing and decreasing. Huh? Okay. You can put the U. Okay. Next, we're going to find our POIs, our points of inflection. Does anyone remember how to find the POI? It's between the concavities. So it's the max and min, the average of that max and min, right? So in this case, it's going to be on the midline. So on our midline, so our first POI is at perfect, 5/3. And our second would be at, this still would be considered the POI. And not in this window because it doesn't graph continue. If that showed a continuation, then we can make a prediction of what's taking place. The graph stops. How we feel? Guess whose turn it is? You're so smart. I knew it all along. All right, so you're gonna do example 10B. Ooh. Is what? Negative. You're starting at 0.3. Remember, your starting point would be for a cosine would be where your maximum value is on your intercept, right? On your not intercept, your x axis, y axis. Wake up, Sean. So you're doing all four parts. Key points, concave up, concave down, increase, decrease, and POIs. Mm-hmm. Yep. Or wouldn't that be down? 0 to pi? I was like, 0 to pi is down. Your POI would be at pi. They're ends of it. So like you notice how this end curves? You can make a prediction of what's going to take place, right? So you know that this is going to be concave down. Well, because more of the graph is drawn. On the other one, did the graph go past the y-axis? No. Yeah. I would assume they would want you to prove that that's concave down. Like that's an interval of being concave down. I don't think it's going to hurt you to put it because it's a continuous oscillating graph. So I would include the concave down in my answer. When is it concave down? Right here. This. Like, yeah. So like this is your period. Yeah. So, but you're saying it's concave down from 0 to pi. And then this is concaved up because these are your POIs, right? These are the points of inflections where you're changing concavity. So if I'm saying that this is concaved up, then it had to come from somewhere being concaved down. Does that make sense? The function is concaved up from pi to 3 pi. It's not.
Like it could have the POI. You have to use a POI. That's the middle. Because it levels out at at x equals 0 and x equals 4 pi. I mean, it's not because the rate of change
is 0.
Wait, do you see too?
If you feeling funky. Do we want to go over B or do we need a little more time? Okay. Okay, how do we do on B? Good. All right, on C, give it a shot. What do you notice about this function? And what else do you notice? It's negative. It's a negative sign. Okay, on this one, I want to point out that when you were given a number, not a number line, an x-axis that is counting by something not similar or easy, you want to establish what is 1 unit of it, right? So if I look right here and I know that I'm at a half and then it goes to a pi, that tells me that halfway between 0 and a whole is a quarter, right? So that means I'm counting by quarters on each one of these, correct? So this is 1 quarter, 2 quarter, 3 quarter, 4 quarters, 5 quarters, 6 quarters, 7 quarters, 8 quarters, 9 quarters, 10 quarters, 11 quarters, 12. Okay. What they did along the way is they just simplified, right? So that's how it established what my values are for my 5 key points. So for your 5 key points, you should have 0, 0, 3 pi over 4, comma, negative 4, 3 pi over 2, comma, 0, 9 pi over 4, comma, 4, and 3 pi, comma, 0. Yes? For your concavity, where am I concaved up at? 0 to 3 pi? I would consider 0 this time because what does it show me? But I do know that it changes directions. So I know it's increasing, and at some point it's going to have to do what?
You know that.
Because if I establish this as the sine graph and it didn't limit me by stopping it, I have to assume that it's going to keep oscillating. Concave down. Where am I There we go.
You know, it goes to where the point of inflection is.
Where the POI is. From one POI to the next. So your C, your interval of increase. Go 3 pi over 4 to 1. 9 pi over 4. You increase from here up until here, which is that 9 pi over 4. Where do you decrease? 0 to 3 pi over 4. And 9 pi fourths to 3 pi. And so based on all of this, what are my POIs? Perfect. Geniuses. Never doubted you. I did not. Okay, we're going to look at a possible FRQ. Or a type of problem. A buoy oscillates as waves go past. For any given time, it moves a total of 4.5 feet from its low point to its high point, and then returns to a high point every 15 seconds. So when we're thinking about this, we're going to establish what pattern is taking place. And why is that? So we're saying it has a min, then a, are you sure it's cosine? You said cosine, right? Yeah. Oh, did you say cosine, right? Oh, yes. We have a min, then we're gonna have to come back up, and then we're gonna have a max, then we're gonna have to head back down, and then we're gonna have a min. So it's oscillating. We're doing min, max, min, max. So what kind of cosine is it? It's a negative, not at the origin. Sine starts here. It says it starts at the lowest point. So I'm starting at my lowest point, and then I'm doing this.
Yeah, why didn't it start at a max and go to the min?
I said it's negative cosine. No. Is it not negative? I think it's negative cosine.
I don't even know it's negative.
Because you're starting at the bottom, and positive cosine starts at the.
I thought it said it starts at the top of the way.
I didn't interpret that. If you look at the waves right here. So imagine that you were drawing here's your equilibrium, 0. Right? I mean, it's probably not the drawn best, but at some point the graph is doing this. No?
Oh, okay. Oh, so it's not,
Do we- Yeah. It's because that's the way I. Yes, every sine can be a every cosine can be a sine. Yep, goes either way.
Why does it not work? Why does I know?
I think just because of where we're at in terms of this problem, how it starts off as a minimum. So like cosine starts off as a max, intercept, min, max, right? I was just saying this was my low point. And I just went high above my equilibrium. Like it's saying I'm starting at a low and then I'm going back up.
The picture would make it a positive cosine later. Probably they're gonna make it a negative.
I don't see it as I see it as a negative cosine. Because if you think about even, well, hold on. I got you. I got you. That shouldn't be there. It would be,
Positive cosine starts up and goes down.
is what you're saying based on the graph, right? Like based on this, you think it should be here. I see it based on the description of what's taking place. I felt that it started here, which would make it a negative cosine.
Most of it does not get done. Oh, a little bit.
Yeah, and then it repeats, and then that's how I visualized it. Is that? I think at this point, if you choose to do it as positive or negative, you would have to have your signs that support it, because there are ones that are equal.
Cycle.
For them, yeah, for me, I know I'm gonna do fine.
Well, because it starts at halfway of that, so that means that the other piece is over here. Do you hear me, Lydia? So it's only at the halfway, so that means that the full low point is it's doing this.
Wait, are you just gonna wait? Are you gonna?
Yeah.
Wait, so would the amplitude be?
It would be
5, but then the shift would also be 2 points?
yes.
Like that.
Your amplitude would be 2.25.
But is there a shift or is it on?
I don't think I would. There's not a shift. There's a B value. Yeah.
Like, how do you know that you don't have like a vertical or?
I think, and if it doesn't give you enough information, like it's nothing changing up or down, I think you just start off as you have 2 of them now.
We can have like, no, are we having a unit circle quiz this week?
Yes, tomorrow. I told y'all Tuesday.
Oh, I thought you said it's surprise.
No. All right, I'm gonna finish this video for you. All right, so we're doing min, intercept, max, intercept, min. So with the fact that it says that it's only halfway, like of our 4.5, that means that our A value or our amplitude equals 4.5 divided by 2, which equals 9/4, which equals, if you want it in terms of a decimal, 2 1/4, right? So that's going to be our A. And then we know that 2 pi over B, our period, equals 15 seconds, because it takes 15 seconds for it to return to the high point, right? So therefore it's 15 seconds. So then now we can write our equation. We're doing it in terms of distance and time. So we know we were involved with T. So that means our independent variable has to be T. So we have D equals, and like we said in the beginning, it's a negative cosine. So negative 9/4 cosine. And then based on this, our B value, our B would equal 2 pi over 15. So cosine of 2 pi over 15 T would be our. Okay, so what is the frequency? Remember that frequency is the reciprocal of your period. Of your period. And our period for this problem was 15 seconds. Was 15 seconds per cycle. So therefore, our frequency equals 1/15 cycle per second. Okay, so explain in context. That means it wants you to write a sentence and describing what's happening. So the buoy moves 1/15 of the distance. I would spell distance. Not like I was spelling it. Of the distance per second. Okay, so that's describing that. Now we're going to go into C. C says using a graphing utility to find the point of intersection where the buoy is at equilibrium. Okay, so we want it to be at equilibrium. And so we're going to graph our equation that we got. So I'm going to go to screen, show taskbar, open up Sylvie. I'm going to make sure that it's in radian mode, which it is. Y equals, and I'm going to put in what we discovered. So we have -9/4 help if I can put the 4 times the cosine of 2 pi please excuse the music divided by 15 x. Okay, so that's our equation. I hit the graph. I am still zoomed in from my previous problem, so I'm going to stop the graph by pressing the on button. And I'm going to adjust my window. I'm going to do zoom. Let's see how Zoom Trig treats me today. Okay. Treats me nice. It's doable. It doesn't show me my full cycle on this side. I needed to shuffle a couple more. To this direction so I can see my full cosine curve. So if I go to window, let's go over to 2 pi, maybe too much, but just so that I can see. Oh, it was already at 2 pi, guys. I just realized what I put in. I put in 3 pi, I hope, but that didn't make a big difference. It don't. Dude. You're gonna be wondering, is he listening to me? Okay, so now it's going, it's going, it's going. And we're looking for what are we looking for? Where the buoy is at equilibrium. So we're looking for when the buoy is at equilibrium, which in this case is when it's at its maximum. So we're looking for when the buoy is at its equilibrium, which is when it's at its maximum point. And so we need to figure out what is this point, right? And when do we get that? So we're going to do second trace. And we're going to look for maximum. We press 4. And we're going to go. Yep. And then, so we end up at 7.4999. What's that? 2.25. Oh, I'm sorry, guys. We needed our 0 and I went to maximum. I just found the maximum value for what reason? I'm not quite sure. I think that will be useful when we get to drawing, but Not
It's
useful
still the
for
wrong
right now.
one.
Is it really?
Yeah, I'll take this with me.
Okay.
Two of you that need it. Thank you.
Thank you. So we're gonna find our zero, left bound. And we're gonna have our right bound. And there we go. So our point of equilibrium when we're at zero is at 3.75. So we're gonna put at t equals 3.75 seconds. The buoy is buoy, you know what I'm talking about, is at equilibrium. Equilibrium. And what else had to take place? At this point, the path changes from concave up to concave down, which means that this is a POI. T equals 3.75 a POI. Okay, there's that. Then what was next? The behavior, no, what does equilibrium of the buoy mean in respect to the behavior of the waves? I may have answered that. With respect to the wave in our picture, it looks like what would that look like in terms of the wave? It would be the midline. Let's go back and look at the picture. So if I'm here and the equilibrium is where my yeah, I drew a horrible assessment, which is why this doesn't make sense to me. Sorry, guys. So I get it now. We're here. How is this my x-axis? Okay, so I'm going to say that ideally, based on our graph, it has to be your midline. Based on our graph, the significance of the when it's at equilibrium is that it's the midline of the waves. So I would write equilibrium takes place. I'm writing horrible because I'm trying to write fast. At the midline of height of the wave. Are you waiting on me? Oh. Okay, so then it says identify where the buoy is decreasing. So for where the buoy is decreasing, you are going to, we did know the maximum because that's where I was going with. You're gonna look on the interval, and I need to move my thing over. Let's go to window. It's time, and I don't know why I kept putting in. There we go. So we're gonna see sorry, equilibrium. Oh, a lot happening right here. So we're gonna look for where it's increasing and like where that pattern takes place. Decreasing, I'm sorry. So we know we decrease from our maximum here, and that's why it's like I need to find the maximum at some point. We would find the maximum by second trace forward. I'm gonna go to the left of it. then go to the right of it. And hit enter. So we decrease at about 7.5 seconds. Well, we start decreasing at 7.5 seconds. And then we know to find our minimum, you repeat again. Trace. We're gonna find the minimum. 3. And go down, 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 down. Okay. Oh, I clicked too much. It's stuck. Stop. Stop. My computer is mad at me. And she's okay, quit. It won't stop going to that direction. I pressed it too many times, and this is embarrassing. Stop. I think it's glitching. My computer is glitching. So great. So we're gonna just, not my computer, my calculator, we're just gonna close it out. We're gonna use what we know so far as the graph goes. So we have our graph. So let's just make our own graph. We're here, and we identified that we had our low, which was down here, halfway. We're right here. And then we talked about we meet our equilibrium was at 3.75. So this is at 3.75. And then before the computer went crazy, we had a maximum here at 7.5. And then it's going to come back down. And as you can see here, from 3.75 to 7.5, you could easily calculate the difference here. But we're not doing that. We're worried about when do I go down all the way, which is going to be double this, right? So right here, which is 15-ish, is where I'm going to go. And then I'm going to come back up, right? And it's going to keep going. So it's doing this. Sound effects and all. Okay. So when you're looking for when is it decreasing? Well, it's going to be repeatedly decreasing because you have multiple maximums and multiple minimums along your time frame. But just for our period of time, we're going to be decreasing. Let me see if I make it. If we only focus on right here as a positive cosine. So from here to here, and it's going to stop at, what is that? 22.5. 7.5, yeah, 22.5. So from here to here, we would be decreasing when t equals 7.5 seconds to 15 seconds. So when t equals 7.5 seconds to 15 seconds, and every 15 seconds after. If that makes any sense. Sorry for my computer being weird and having just, we can count though. We can use a little number sense. And also I see what you guys saying, why can't we just analyze it from here and talk about it as a positive cosine, which totally makes total sense. Interpreting it as a positive cosine starting there instead of looking at the minimum value. Okay, well, that's it. That's all we got.